So reasonably, we might ask, well, what would happen if we changed one little thing? Like, let's say the sign of the exponent right here. Well, there's a couple of ways of looking at this. Of course, every single thing that we've said still applies, right? If f of 0 is equal to 1, if we take f of 1, we get a. Well, kind of right here, but we should probably think about it this way. That's written if it's a to the x. What do we do if it's not? What if it's a to the negative x like that? Well, let's make an adjustment right here. If you remember your rules, we're saying that the function f of x equals 3 to the negative x is really the same as saying 3 to the negative 1 times x. Remember that multiplication rule? Here, I'll remind you. A to the m to the n is the same thing as leaky pen, is the same thing as a to the m times n. So we're just reversing course here and say, well, 3 to the negative x is 3 to the negative 1 raised to the x, and that is the same thing as 1/3 to the x. So by that standard, sure enough, 1/3 to the 0 would be equal to 1. And 1/3 to the first, that should be equal to 1/3. And of course, 1/3 to the negative first is 1 over 1/3. Well, 1 over 1/3 is 3. All the other rules apply. This x is in the set of all real numbers, and the range goes from 0 to infinity. Why is the range 0 to infinity? Well, again, let's look at our horizontal asymptote and our behavior. If we let x equal 0, y is equal to 1, just as we said. If we let x equal negative 1, y is 3. And if we let x equal positive 1, in this case, y is 1/3. Now, as we got larger and larger values of x, that is, as x tends toward positive infinity, it looks like y tends to 0 again. So we could say that, well, yes, the limit as x tends to infinity of 3 to the negative x is the same thing as in the last case where we went to negative infinity. That is, our limit goes to 0, and that's our horizontal asymptote, only this time it's to the right. And that's because of the change in sign in our exponent, right? So when we're looking at this as 1/3 to the x, as y is equal to 1/3 of the x, remember, we're actually talking about y equals 3 to the negative x power, and that changes where we get that horizontal asymptote. Since y is always positive, since we take 1 over x, or 3 to the x, and we always get a positive number out, it doesn't matter that that exponent is negative, just as long as we remember that y has to be a number greater than 0 when we take that base and raise it to the exponent. So in this case, we would know that if we have a negative exponent, or if we have a fraction where the base is less than 1, right? The base is between 0 and 1, we know we're going to get this shape where the graph has its horizontal asymptote to the right rather than to the left as it did in the last example.